This is just a summary of factoring guidelines that you might find helpful, and it won't last too long, but let's take a look at some of my notes. Always check first to see if you can factor out the greatest common factor, like I did here, 3x cubed minus 12x squared minus 6x. The greatest common factor is 3x. So do that first, and then check and see if you can factor the trinomial. If you have 4 terms, you probably want to try to factor that by grouping. I didn't do more than 4 terms, but you can actually use grouping for more than 4 terms. But sometimes it works for 5 or 6 terms. But anyway, I'm just going to do it with 4 terms. So here I have 4 terms. Notice in the first 2 terms I can factor out an x and I get 2x squared plus 3. And in the second 2 terms I can factor out a negative 2, and then that'll also give me a factor of 2x squared plus 3. And then if I factor out the 2x squared plus 3, I get 2x squared plus 3 times x minus 2. And of course you can put the 2x squared plus 3 to the right or to the left of x minus 2. If your polynomial only has 2 terms, the first thing you should check to see if it's one of the special formulas of difference of squares, difference of cubes, or sum of cubes. So like for instance, this is difference of squares, so it would factor into 7x plus 4y, 7x minus 4y. This is difference of cubes, so using the difference of cubes formula, this would factor into 3x minus 4y times 9x squared plus 12xy plus 16y squared. But then if it's sum of cubes, then it would basically factor the same way, except the signs would switch. So this would be 3x plus 4y times 9x squared minus 12xy plus 16y squared. And remember, if some jokester tries to get you to trick you into factoring the sum of squares, remember the sum of squares will not factor as far as we're concerned. Now if you have 3 terms, you can check to see if it's a perfect square trinomial. And so like for instance here, I know this is a perfect square trinomial because the first and last term are perfect squares. And if you check the middle term is double what 2x times 7 would be, which is the square roots of these 2 terms. So 2x times 7 is 14x, and the middle term is double that. And then on this one, I know this is a perfect square trinomial because the square root of this is 5x, the square root of this is 3y, and if you multiply 5x times 3y, you get 15xy, and then if you double it, you get 30xy. So both of these are perfect square trinomials. Now if it's not a perfect square trinomial, you can factor it as a general trinomial. You can try trial and error like I did here, or you can do the grouping method where, remember, with the grouping method you multiply a times c and get negative 72, and then your b value here is 1. So you're looking for 2 numbers whose product is negative 72 and whose sum is 1. So I'm going to use 9x minus 8x. So I can replace this x with 9x minus 8x, and then I can factor these 4 terms using the grouping method by factoring a 3x out of the first 2 terms and a minus 4 out of the last 2 terms, and then I get a common factor of 2x plus 3 here, and I can factor the 2x plus 3 out of here either to the right or the left, and then the other factor I'm left with is the 3x minus 4. Now when you have a trinomial, remember if the coefficient of the square term is 1, then it's usually quicker then, because all you have to do then is just put x here and x here, and then you find 2 numbers whose product is this 3rd term and whose sum is the coefficient of the x term. In this case it's minus 5 and minus 2, so the factors in x minus 5, x minus 2. And then the last thing I want to mention before we leave this section is make sure that don't just pat yourself on the back once you factor something. Always check the new factors and see if they'll factor further. For instance, here, x to the fourth minus 256 factors as difference of squares into x squared plus 16, x squared minus 16. But then, x squared minus 16 will factor into x plus 4 times x minus 4. So you have 3 factors there. Here's one you can factor by grouping. If you take these terms here and then these here, the first group I can factor out of x cubed, and I'm left with x squared minus 4. The second group I can factor out of minus 8, and I'm left with x squared minus 4. Then I can factor the x squared minus 4 out of these two, and I'm left with x cubed minus 8. Now, what's interesting is both of these factor, x cubed minus 8 factors as difference of cubes, and x squared minus 4 factors as difference of squares. So I'll leave you to verify the formulas here, but x cubed minus 8 factors into x minus 2 times x squared plus 2x plus 4, and x squared minus 4 factors into x minus 2, x plus 2, and then that can be rewritten as x minus 2 quantity squared times x squared plus 2x plus 4 times x plus 2. And then the last one here, I'm going to factor out the greatest common factor, which is 3xy. And then when I factor out the 3xy, it leaves me with a trinomial of x squared plus 2x minus 15, which I can factor that into x plus 5 times x minus 3. So the final factor would be 3xy times x plus 5 times x minus 3. Well, that pretty much finishes this unit on polynomials and factoring. So happy factoring.